Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into a crucial aspect of operating system design, kernel data structures. Sheila, why don't you kick us off with a brief explanation of what kernel data structures are?
Certainly, Victor. Kernel data structures are the building blocks that operating systems use to organize and manage information efficiently. They're like the scaffolding that holds the entire OS together, allowing it to perform its tasks smoothly and quickly. These structures are fundamental to how the kernel, the core of the operating system, functions.
Great explanation, Sheila. Let's break this down further for our listeners. What are some common kernel data structures that OS developers rely on?
The most frequently used kernel data structures include lists, stacks, queues, trees, and maps. Each of these serves a specific purpose in managing system resources and processes. For example, linked lists are often used to keep track of running processes, while trees might be employed for file system organization.
Absolutely. And it's worth noting that the choice of data structure can significantly impact the performance of an operating system. Sheila, could you give our listeners an example of how a particular data structure might be used in a real-world OS scenario?
Of course! Let's take the process scheduler as an example. Many operating systems use a priority queue to manage which processes should run next. This allows the OS to quickly select the highest priority process without having to search through all running processes every time it needs to make a scheduling decision.
That's a great example of efficiency in action. Now, for those preparing for interviews, it's important to understand not just what these data structures are, but why they're chosen for specific tasks. Could you elaborate on that, Sheila?
Absolutely, Victor. The choice of data structure often comes down to a trade-off between time and space complexity. For instance, while a simple array might be faster for small datasets, a balanced tree structure like a red-black tree could be more efficient for larger datasets, especially when frequent insertions and deletions are required.
Excellent point. And speaking of interviews, a common question might be about the difference between user space and kernel space data structures. Can you touch on that briefly?
Certainly. The key difference is that kernel data structures operate in privileged mode, which means they have direct access to hardware resources and can perform sensitive operations. This means they need to be extremely efficient and robust, as any failure could crash the entire system. User space structures, on the other hand, are more isolated and have less direct impact on system stability.
That's crucial information for anyone looking to understand OS internals. Now let's talk about how these data structures have evolved. Are there any modern trends or innovations in kernel data structures that our listeners should be aware of?
Great question, Victor. One interesting trend is the increasing use of lock-free and wait-free data structures in multi-core systems. These structures allow for better concurrency and can significantly improve performance in multi-threaded environments. Another development is the use of more complex hybrid data structures that combine the benefits of multiple traditional structures.
Fascinating stuff, Sheila. As we wrap up, what would you say is the most important takeaway for our listeners regarding kernel data structures?
I'd say the key takeaway is that kernel data structures are the unsung heroes of operating system performance. Understanding them is crucial not just for OS developers, but for anyone working on performance-critical software. They're the foundation upon which efficient and robust operating systems are built.
Excellent summary, Sheila. To recap, we've covered the definition and importance of kernel data structures, common types like lists, stacks, and trees, their real-world applications in OS components like schedulers, and the trade-offs involved in choosing the right structure for the job. We've also touched on the differences between kernel and user space structures and modern trends in the field.
That's right, Victor. And remember, listeners, understanding these concepts can give you a significant edge in interviews and in your work with operating systems and high-performance software.
Thanks for tuning into Operating Systems Crashcast. We hope this episode has been informative and engaging. Until next time, keep exploring the fascinating world of operating systems.